So next one is default methods. If you have a look at the source code of comparator interface, you can see there are many methods. Then didn't I say a single abstract method? That's what the functional interface should have. Yes, I said a single abstract method, not single method. So in the comparator interface, there is only one abstract method called compare. The other ones are either static or default methods. Then what are default methods? As you can see, interface now has some method body here with this default keyword. Well, which means now Java support multiple inheritance. Actually, Java did support multiple inheritance before, but it was multiple inheritance of types. Now it supports multiple inheritance of behavior, but that means it's just behavior. So no shared state, which means there is no problem caused by multiple inheritance, unlike C++. C++ shares that state, so it has problem. But in Java, it shares only it inherits only behavior, so you don't need to worry about that diamond problem. Well, I'll give you some examples, and then you can easily understand how it works. So will be to here examples. Okay, I'll create another class called default methods examples. So default methods examples, and here I'll create interface called type1. I'll make it really simple. So, and it has one method, one abstract method called getName. So, and I have class named class1, and which implements the type1. Then, as you know, if I do that, I have to implement that abstract method in type1 interface. But in Java 8, what I can do is I can do this, right? So string the name. So now it can, with the default keyword, I can have method body. So it returns something really simple, just type1. And if I run that getName method on class1 and getName, what I get is type1, because this one doesn't have implementation, but its interface has it. So it uses that default method. What happens if I override that? Well, that's obvious. You will use that concrete one. So return class1, then obviously it will use that one from the class. So I will get class1 now. Yeah, class1. Okay, that's good. Now I have another type called type2, which extends type1, and there is no default method here. So then create another class called class2, which implements type2. So then what happens? Well, have a look at this. What happens if I call the method, right? That can name method on this class 2. And think about this one. Type1 has default method, and class 1, which implement this one, has its own implementation, so it will use this one. And type 2, which extends type 1, has no default method, and a class 2, which implement this type 2, has no implementation of that getName method. So what happens is it checks when it doesn't have that implementation of abstract methods specified in the interface. It checks the interface and see if it has default method, or it doesn't have. It checks its super interface, and then if that has default method, it uses it. So if I do this, I should get what? This one doesn't have that one doesn't have that any method there, no implementation in here. no default method here, so it will use the type 1's default method. So I'll get here class 1 for this class 1, and for class 2 I'll get type 1, right? Yeah, that's there. Then what happens if I put default method here? So string get name and then returns simple type 2. What happens is I'll get type 2 for this, class 2. Yep, because again hierarchy is like this: type 1, type 2, and class 2. This one has default, this one has default, this one has nothing. So there's nothing, so it checks its interface. It has default method, it just uses that instead of checking further. It doesn't check further, just use that closest one. So it gets the default method from more specific type, right? That's why I got type 2. Then what happens if I just do, if it implements both type 2 and type 1? Again, the same thing I said, 1, 2, and class 2. And type 2 is more specific, it's closest to type. So it just uses the default method from type 2 instead of, from type 1, it uses one from type 2. So I'll get type 2 as a result, right? Type 2. Doesn't matter if you change the sequence of this. It's just more specific type. So, alright, it's type 2. Okay, now I have completely different type. So it has nothing to do with the type hierarchy of type 1 and type 2. It's called new type, but it has the same method signature and the same with the default method. So it returns new type. So what happens if I just implement that new type? Okay, now I get compile time error because this one and that one has same method signature. So I have to solve the problem. Well, what can I do? I can implement the class's own implementation, so it may say class 2 like that. Problem solved. Let's put the override. Oops. There too. No, not there. Here too. So if I run it, I'll get class 2. Right now I get the class 2 from this implementation in the class 2. But if I don't have it, if I want to use one from the interface, then what I can do is I want to use this one from type 2, then I can say type 2 super, then get name, right? And if I run it now, I can get type 2. Okay, type 2. So that's the syntax that you use to call that super interfaces, interfaces default method. Now if I want to use the method from new type, I can do new type dot super dot get name, run it, then I get new type, right? So type 1, and then there's new type, and type 2 inherit from type 1, and class 2 inherit from type 2 and new type. So these, all of them have default method. This one has nothing, so you have to specify which one you want to use, or you have to write its own implementation. So with that syntax, you can choose to use new type's default method or type 2's default method. Alright, so can I also use type 1's get name method? Well, try it. You cannot. You get compile time error. You cannot just bypass that type 2 and use its the method from the super interface of its interface, right? So you cannot just bypass that type 2, right? What happens then if I just remove that? Can I use that type 1's? No. Well, then proper way would be just doing this. If you do that, what happens is type 2 doesn't have its default method, so it will use type 1 will use type 2 will use type 1's the default method. So now you get type 1, right? So type 2 has nothing, and if you do type2.super.getName, it doesn't have anything, so it will check if it's a super interface, and it has that, so it has default, it uses that, like that. So that's how you specify that default method from its interface in the class. And then, so what happens if I have abstract class? Let's call it abstract class 1, and it has the same method. What a coincidence. So get name, and it returns abstract class 1, and then abstract class, and this one extends that abstract class 1. Now I remove this one. What happens? Can you guess? Well, it will return abstract class 1 because this is class. Okay, class wins in this kind of battle of inheritance of behavior, that obviously class wins, and then it returns that abstract class 1. But here, of course you can have your own implementation for that get named, right? So I can do like this, class 2, like that. Yeah, now it gets class 2, or you can specify well, the same thing, if you want to call that get name from this super class, you can just do that. From interface, you don't want to use one from that, but interface, sorry, from interface you can do like this. Well, as I said, you can't really do this because it has more specific type. You have to use that. It can use the closest one. So do like this, right? Or new type. It works too. Okay. So that's how you can solve the problem when there is conflict between the method name of one type and another type. Okay, if you have the conflict in method names of class and interface, it doesn't matter because class always wins. So doesn't matter if it's actually abstract or normal, just normal concrete class, doesn't matter, class always wins. Okay, so that's default method. So this is how you can have the multiple inheritance of behavior in Java 8. So it is useful, and it makes, as I said in the beginning, it makes a functional interface more versatile. Why? Well, if you have a look at the code for function, it has one abstract method and some other default methods, compose and then, and well, this is static method. Or if you have a look at predicate, it has and, negate, or this one is static. So few other default methods. So how can it be useful? Well, see this one. So you have predicate of string, and the name of it is null. Okay, is non-null or just non-null. And then you use lambda expression. So say s and s not equals null. All right. You have another predicate called predicate of string and called not empty. So s, same thing as, okay, if s is not empty, then it returns true. You have this kind of predicate, and then what you can do here is, let's say if you have, you can do like this, non-null, then and not empty, and test it and pass, for example, okay, just value 1 and null. 2, 3, and 2 is empty string, 3 is something. Okay, now print out the result of each case. So you test value 1. Oops, I put single quote there. And value 2, value 3. So what would be the result? The first one, null. So it should be not null and not empty. So this one is what? False. This one should be not null and not empty. Value 2 is not null but it's empty. So you will get false. Third one is not null and not empty. So true. So false, true, true. False, false, true. Yep. False, false, true. You got like that. Or you can do something like this: not null or not empty, then test that value 1, 2, 3. Okay, so and what would be the result of the first well, this one actually gets null pointer exception, right? The second one would be true because it is not null. Yeah? This satisfies this one, so it doesn't check further. So it doesn't care if it's empty or not because this one satisfies the first condition. So this one true. Third one, not null or not empty. This one is not null and not empty, so which means it satisfies both. So as soon as it satisfies first one, it doesn't check. So well, true. So null pointer exception, true, true. Run it. Yeah, I expected it, right? Null pointer exception where in there, right? Because you know that's S would be null and it calls something on null reference. So okay, just comment it out. Run it. Then the last two results would be true, true. See, true, true. Okay, so it becomes, you know, your predicate functional interface is, you know, it's really versatile, right? Much more versatile than before without that default method. It's possible because of default method, right? Function as well, you can do one thing and something else, right? So for example, let's do it okay, string, and then returns another string, and prefix adder, and what it does is it adds some prefix. So do the hash and plus s, and if you just okay, what is wrong? Yeah, and if you just use this and apply some value like let's say test, I will return hash and hash, right, like that. But if I do something like this, I have another function called what should I do? Wrapper, and then it wraps that string with curly braces. And what can I do is prefix adder, then and then use wrapper, then apply to this test. What would be the result? Well, I would get you know, this hash and then test wrapped in curly braces, right? So something like this. Okay, that's what I should get. Yep, I got that. So it's more versatile because of that default method. You know, it already has implementation. Okay, so yeah, I'll give you I gave you some examples of you know, that multiple inheritance of behavior, and then, you know, how it can be used like that, right? So I'll give you more practical examples when I give you more examples. I mean, after explaining about Stream API.